Hello everyone, and welcome to a series where we talk about object-oriented design patterns. Today, I will talk about the creation of factory pattern. In general, this pattern is used to decouple object creation from the class constructor call, hide object creation details or delegate the details to a subclass, and create objects in the runtime without necessarily knowing their concrete class. I will put the pattern into a context I understood best when trying to grasp its usage, and that is in a video game. Suppose you're playing a game that spawns enemies in front of you and you shoot them up. While building the game engine, you want to abstract out the creation of each and every enemy into a spawner class that will handle all the details of spawning an enemy. According to your score, or at random, different enemies will appear in the game. This will translate into two class hierarchies, one for the NPCs that can spawn, and then a parallel factory hierarchy for those NPCs. Here is a UML diagram for the patterns example. One can implement the abstract class NPC as I have done with the Goblin class with many different NPCs of his choice, accompanied by their corresponding factory class which will handle initializing them. The creators, or factories, are the objects that will get passed into the spawner class we talked before in order to handle spawning objects. All the code of the examples will be available in my GitHub for convenience. And now let's get on to writing the code for the factory pattern. Okay, so this will be a spawner class. Let's say that this is the class that's gonna be in our game engine and is responsible for spawning NPCs. You see here I'm gonna use a shared pointer as this is modern C++, and this is just placeholder code. These are not concrete, we're gonna fill this up later. So this is gonna return, it's not gonna return an NPC factory, this is placeholder code. Let's go ahead and make a new class. So this is gonna be our NPC, and now an NPC factory. So right now we have two hierarchies, an NPC and an NPC factory. We're gonna make the NPC factory a virtual, an abstract class. So we include NPC. And yeah, include standard shared pointer from memory. So this is our factory method. It's gonna create a new NPC, and we're gonna make this a pure virtual function. So this class is an abstract class, like an interface in Java. The NPC, just for style, it's gonna have some health points, it's gonna have some mana points, and it's gonna have a constructor. And of course, it's gonna also have a virtual destructor, because we're gonna extend this. Always remember to include the virtual destructor. So now let's create our Goblin class. Our Goblin class is gonna extend the NPC class, and the NPC class will also have a string just the a string method, a method that returns a string, which is gonna also be virtual. Or I should say purely virtual. We're implementing the attack method of Goblin so that it says that the Goblin is attacking. And now let's go to the factories. We're gonna create a new factory, a Goblin factory. That it's gonna extend the NPC factory. What am I missing? Yeah, it's gonna extend the NPC factory. And it's gonna return a shared pointer of Goblin. Parentheses and close. So now we're ready. Go back to main, include our factories, and now the spawner class can get a factory, an NPC factory, and create a new NPC without knowing whether this is going to be an NPC, a goblin, an orc, or whatever. So we create our goblin factory and a spawner, and the spawner can spawn goblins, just like that. It doesn't know what's gonna spawn, but we do. So this NPC is gonna attack. Let's see that everything builds and everything runs. Of course, this is gonna return a string, so we print that string, and there you are. The goblin is attacking.